Hello, myself Bhargov Borah, along with my teammates Baranya, Kalita, and Himon Jakharia. Our proposed system is design of a vehicle accident detection system with alert messaging and location reporting. We are here to explain about the fact that due to rapidly increasing population and day by day uses of vehicle, that is more number of accidents which leads to more number of death. This is happening only because of low prior information is given about the exact location where the accident has taken place. The main intention of this project is to find the accident spot area and interacting it to emergency services through the GPS and GSM networks. Here, the GSM technology is used to establish the cellular connection and the GPS module is used to trace the position of the vehicle. The main objective of this project is to minimize the death rate resulting of vehicle accidents and to enhance the security of vehicle and human beings. These are some of the literature reviews we have been through. Now, the GPS module that we have used in our prototype is the Neo 6M. It can track up to 22 satellites and identify location. The operating voltage of the module is 2.7 to 3.6 volt and it consumes current around 45 milliampere. The next module is the GSM module, that is SIM 900A. The GSM network is used to provide the communication from one place to another. Its operating voltage is from 3.2 volt to 4.8 volt. The command that are using to provide communication are AT commands, and the AT command specifies the GSM technology and are related to SMS services. Next, the sensor that we have used here is the MPU6050 module. It consists of 3-axis accelerometer and 3-axis gyroscope. It helps in measuring the acceleration, velocity, orientation, displacement, and many other motion related parameters of the system. It consumes around 3 volt to 5 volt. Next, we have used the LCD display. In our project, the LCD is used to display the status and position of the vehicle. Its operating voltage is from 4.7 volt to 5.3 volt and it consumes current around 1 milliampere. Next we have used is the buck converter, that is the LM2596S. The range of the input voltage is from 3 volt to 40 volt and the range of the output voltage is from 1.23 volt to 37 volt. The maximum output current is 3 ampere. Next we have used the Arduino, that is Mega 2560. The input voltage is from 6 volt to 20 volt. It comes with more memory space, bigger size and more input-output pins. Next, coming to the working of the prototype. When the MEM sensor detects an accident, it triggers the GPS. The GPS from the satellite gives the information about latitude and longitude. Then to the GSM, it gives both the cellular information and also the location where the accident has occurred to the server. This server passes information to the emergency services. One more feature is when any authorized people gives missed call to GSM at accident location, then it sends message of the accident location. Now,
in phase 1, we basically done the project in simulation only. The hardware used are Arduino UNO, GSM, GPS and vibration sensor. The block diagram for phase 1 is shown here, where the model will start as the vibration sensor takes the input. It will then send its value and location with the help of GPS through the GSM. In phase 2, we have implemented all the hardware components. The hardware used are Arduino Mega, GSM, GPS, MPU6050. For better precision, we have used the MPU6050 instead of the vibration sensor. And we have used Arduino Mega for better perfection. The block diagram for phase 2 is shown here, where the model will start as the MPU6050 takes the input. and it exceeds its threshold. It will then send its value and location with the help of GPS through GSM. In the start, the model will start and introduction is displayed. A certain threshold value is set. When the input of the MPU exceeds its threshold, it will take the location with the help of GPS and send the value through GSM to the registered mobile number. If it is less than the threshold, it will not start. When we give a missed call to the attached number of the GSM, it will send back its location once again.
This is the final prototype of our project. The first picture shows the system at idle state, the second picture shows the system after collision, and the third picture shows the alert message which is sent to the emergency contact. The advantages of the project are such that without any delay, the vehicle involved in an accident can be identified using tracking technology. Also, the accident victims in remote areas will receive immediate medical attention. The limitations of the project are such that it is difficult to communicate in some areas where GSM networks are not available. Also, users need to regularly monitor the entire system. This is the final conclusion of the project. This project provides an efficient, effective and optimized design gadget that has many benefits. This system uses the microcontroller interfaced with GPS and GSM and sensors with aim of reducing the response time and giving the location of accident accurately. It can work on the issue of lack of automated system for the detection of accident and locating accident spot. As a result, the time for detecting the site is reduced and the person can be treated as soon as possible, which will save many lives. These are some of the future scopes which will make the existing system more advanced and more useful to the people. A wireless webcam can be added in this for capturing the images, which will help in providing driver's assistance. A dedicated app can also be developed with proper user interface. IoT can also be used in this system to connect a nearby vehicle to make it more precise. These are some of the references of research papers related to the project. These papers provided many useful and important ideas to execute the project.